All right, now we're going to add and subtract complex numbers, but they're going to start in a graph. All right, so let's start by labeling each point here. It says take Z1 minus Z2. Well, Z1 is at the following coordinates. It's at -7, 5. Z2 is at -7, -3. I remember this was Z1. This is Z1. This is Z2. So let's take Z1 minus Z2. So let's do that. Let's subtract like that. So if we take -7 minus -7, that's actually 0, right? 5 minus -3. What happens when you take 5 minus -3? You end up adding, right? So 5 plus 3 is 8. So now we have to take our point here. It wants us to plot the answer. So 0, 8. There we go. That's how you add or subtract complex numbers. Next assignment to take a look at. Let's do the distance of complex numbers. So the distance of complex numbers, we're going to use the Pythagorean theorem. All right, so let's zoom out here a little bit. It says find the distance between Z1 and Z2. Let's plot the points, all right? So, or let's write down the coordinates for Z1. Z1 is at 7, 1. Z2 is at 2, -7. We can either use the coordinates or we can use a more geometrical approach. I prefer the geometrical approach. I'm going to sketch a little triangle here. Ooh, I got to zoom in to do that, I think. We're going to sketch a little triangle. And if we do that, we notice we get a right triangle. And we're going to use the Pythagorean theorem. We're going to notice that this side, this top side, is a length of 5. The other leg of the triangle has a length of 8. So let's do 8 squared plus 5 squared equals c squared, right? So we're not actually going to say c squared. We're going to call that c. In this question, they actually call the distance d, right? So find the distance d. So that's going to equal d squared. That's 64 plus 25. If we add those up, we get 89. That's d squared. Now, in order to solve this, we should take the square root. If you do that, the square root of 89 is not a whole number. So we're going to just write the square root of 89. The last assignment is the midpoint of complex numbers. So if we're finding the midpoint of two complex numbers, we're finding the average in between each part. So the midpoint, let's compare the two real parts of the complex numbers. If I want to find where do 2 and -6 have a midpoint, I want to add them up and divide by 2. This is the same thing as finding the average of two numbers, right? Add them up and divide by how many there are. There are two numbers. So that spits out -4 divided by 2. So the first part of our answer is -2, right? -4 divided by 2 is -2. We should do the same thing with the i's. 4 minus 3. Sorry, 4 plus -3 divided by 2. That will spit out 1/2. So plus 1/2 pi. says express your answer in rectangular form, which is what we did. That's how you find the midpoint. Let's do one more of these. It says plot the average M of Z1 and Z2. It's the same thing. Find the midpoint. It's the same thing. Find the average. So take a look at Z1. Z1 has the coordinates 8, 4. Z2 has the coordinates 2, -4. What is exactly halfway between, or what is the average of 8 and 2? Well, we can add them up. Find the average by dividing by 2. 8 plus 2 is 10, divided by 2 is 5. For the other part, let's do 4 plus -4 divided by 2. Well, 4 plus -4 is 0, and 0 divided by anything is 0. So the average is going to be 5, 0. Now, if you do it right, it should appear to be about halfway between the 2 points. And it looks like we're good.